We're now going to look at some key ideas about domain. We're going to review what we already know about domain and look at domain with logarithms. Okay, radicals. Odd radicals are fine. So the cube root, the fifth root, the seventh root, there's no domain restrictions. The answer is going to be all real numbers. But even radicals have a problem if there's a negative under the radical. So fourth root, square root, sixth root, any even radical, you must take what's underneath the radical and set it greater than or equal to 0. And that's going to be your domain restriction. Now fractions, we cannot have a 0 in the denominator because dividing by 0 is undefined. So you must take what's in the denominator and make sure it does not equal 0. And that's your domain restriction. For logarithms, you cannot take the logarithm of a negative number, and you cannot take the logarithm of 0. So what you have to do is you have to set what's inside the log greater than 0. And that's going to be your domain restrictions. We will do several examples right now. These first examples are reviewing what we already know about domain. So in this first example, we have an even radical. So we must take 2 minus x and make it greater than or equal to 0. So 2 minus x must be greater than or equal to 0. Now, in order to solve this, I need to isolate the x. I'm going to actually move the negative 2 over. So I have negative x is greater than or equal to negative 2. Now I'm going to divide by negative 1 to isolate the x. Remember, when you divide by a negative with an inequality, you must reverse the sign. So x is going to be less than or equal to positive 2. Remember, that's the sign that you reverse anytime you divide by a negative. So in inequality notation, it's x is less than or equal to 2. In interval notation, it would be negative infinity to 2, close bracket. Now for this example, we also have an even radical. So we have a 4 here. So we must take what's underneath the radical and make it greater than or equal to 0. So 3x minus 4 is greater than or equal to 0. 3x is greater than or equal to 4. Divide by 3, divide by 3. X is greater than or equal to 4/3. In interval notation, that would be 4/3, comma, infinity. That's our domain for those two examples. For this example, we have a fraction and a radical. Now, the radical is an odd radical, so there's actually no domain restrictions with this radical. But we do have the cube root of 2x minus 7 in the denominator, and we cannot have that denominator equal to 0. So we must take the cube root of 2x minus 7 and say it does not equal 0 and solve that for x. So 2x minus 7 does not equal 0. 2x does not equal 7. X does not equal 7/2. For this problem, the domain is all reals except 7/2. Or in interval notation, it would be negative infinity to 7/2 or 7/2 to positive infinity. This is our first example that contains a log. Inside of the log must be bigger than 0. So we must take 1 minus 2x is greater than 0 and solve for x. So once again, I'm going to subtract 1. So I have negative 2x is greater than negative 1. Now I'm going to divide by negative 2. And remember, when you divide by a negative, you must flip the sign. So I'm going to flip that sign. So I have x is less than 1/2. So our domain, so this is inequality notation, x is less than 1/2. In interval notation, it's negative infinity to 1/2 parentheses. Here's another log example. So we must take what's inside the log and make sure it's greater than 0. So x minus 2 must be greater than 0. So x is greater than 2. We go from negative infinity to 2, open parentheses. Now, just so you know, this plus 4 is outside the log, so we don't really need to worry about it because it is not going to cause any domain issues. The practice examples are already worked out for you. Please check what you did and fix them if you made any errors. This last example has multiple things going on. First of all, there's an even radical inside the log. So I must write x minus 4 is greater than or equal to 0. Now the log, this whole expression right here, has to be bigger than 0. So the fourth root of x minus 4 minus 2 must be greater than 0. We also have two fractions in the denominator. So 2x plus 7 cannot be equal to 0. And last but not least, we have another fraction in the denominator. So x minus 25 cannot equal 0. So now we need to solve all of these and look for the most restricted in this particular situation. So we have x minus 4 is greater than or equal to 0. So x must be greater than or equal to 4. Okay? Now this problem, we need to add 2 to both sides. Add 2 to both sides. So the fourth root of x minus 4 is greater than 2. Now in order to undo that fourth root, we need to raise that to the fourth power. So what we have is x minus 4 is greater than 2 to the fourth, which is just 16. And then we need to add 4 to both sides. So x is greater than 20. Over here, we have 2x does not equal negative 7. X does not equal negative 7 halves. And lastly, we're going to add 25 to both sides. So x does not equal 25. Now we need to look at all of our possible domain restrictions and look for the most restricted. In this particular situation, x plus 4 is not as restricted as x plus 20. So not x plus 20, x is greater than 20. So x is greater than 20 is our largest restriction. Now, if you think you might have made a mistake, let's look at a number, right? Plug in 5. 5 minus 4 would be 1. The fourth root of 1 is 1. 1 minus 2 is negative 1. We cannot have we can't take the log of a negative number. So we need to go more restricted. The minute we get to the 20, we get 20 minus 4 is 16. The fourth root of 16 is 2. 2 minus 2 is 0. Okay, that's where it starts to be 0, but we want all numbers greater than 20. So this is definitely part of our restriction. So we need to be more restricted than that. We need to start with x is greater than 20. Now over here, x can't be equal to negative 7 halves. Well, x is already greater than 20, so this is already not in our domain, so we don't need to worry about this. But 25 is in fact bigger than 20. So this we also need to worry about. So these two things are part of our domain. So x is greater than 20 and x can't equal 25. This is our domain in inequality notation. In interval notation, it would be 20 to 25, parentheses, or 25 to infinity. This is the same domain in interval notation. These examples have already been worked out for you, but one thing to note on practice B is you have to deal with both what's inside the log, which must be greater than 0, and what's inside the even radical, where x minus 1 is greater than or equal to 0. When you solve inside the logarithm, you discover that the square root of x minus 1 is greater than negative 3. Well, since this is always going to be a positive number because the square root of a radical is always positive, this part is always going to be bigger than negative 3. So this inequality has already been dealt with. There's no domain restrictions that come out of this inequality. But the x minus 1 is greater than or equal to 0 does have some domain restrictions. When you solve that, you end up with x is greater than or equal to 1, which means that this is our domain restriction, since this, the square root of x minus 1 is greater than negative 3 does not in fact have any domain restrictions. So our final answer for our domain is x is greater than or equal to positive 1.